What's going on, everybody? Thank you for tuning into my channel and I appreciate you. Much love, much love. Anyways, so the topic today at hand is integration. Integration, I get this question all the time, everywhere, in calculus, in college algebra. What is integration? And today, finally, I get an answer for you. So the big idea here of integral calculus is the calculation of the area under a curve using integrals. Alright, now what does this have to do with differential integrals? Alright, or differential calculus? You've got to stick around to find out. Alright, here we go. So assuming you're given a problem like this and you're told to find the integral of this problem. So to begin with, this whole problem is referred to as an integrand. Such this polynomial here is referred to as an integrand. And this S, this is the symbol for integration. It's an elongated S, which denotes integration. All right. So, in brief, integration is basically the opposite of differentiation. So, assuming that during differentiation, you end up finding f dash with integration, you go back to find f. So assuming you started off with f to find f dash, and that is by taking the derivative, and now taking the integral, you would just go back from here to here. So it's pretty much very opposite to each other. Alright, so let me just give you a general formula of how to find the integral of a certain function. So assuming I have my function here as n, alright, and n maybe, sorry, let me scratch that. Assuming I have an x to the n, alright? So x is my function and n is my power. Alright, so the basic principle of integration denotes that to find the integral of this function right here is the same as saying x, take the power, you're going to add 1, and then you're going to divide by the power, and the power is n plus 1. Okay, so this is the general formula of integration. I do have two problems that I'm going to go through, and hopefully by the end of these two problems you will be able to at least get an idea of how to integrate certain functions. Alright, so without further ado, let me just jump right into the first problem here. Okay, this was my problem number 2. Take this away here. So problem number 1, I have integral of x to this third plus 5x squared plus x plus 1 and dx. Alright, so like I said, from our general formula, we're gonna integrate term by term. So we'll start with the first term and the second term, third term and fourth term, and at the end of it all we'll just combine it all together to form one answer. Alright, so let's get started. So here I have x cubed, and taking the integral of x cubed, that's gonna be x. Remember, my n now is 3. So, and we said that you take 3, you add 1. That's what the general formula says. So I'm gonna take a 3, I'm gonna add 1, and then I'm gonna divide by the total of my power, and in this case it's 3 plus 1. That gives me a 3 plus 1, which or 4. All right. Excuse me. So that is the first term right there. Plus, let's jump on to the next term. I have a 5x. Now I have a squared. All right. So it's just going to be 2 plus 1. Always add a 1 on top of your power. All right. Divided by. Now we divide by the total power, and the total power is 2 plus 1. That gives us a 3. Boom, finished. Nice and easy. Alright, on to the third term. Third term is just an x. Now, if it's just an x, that means my n power is just a 1, because it's an invisible 1, alright? So in that case, it's just going to be 1 plus 1 all over 1 plus 1 is 2, alright? Boom! Third term. Let's jump onto the last and final term. Now my final term is just a 1, which is a constant, alright? Now, taking the integral of a constant just winds up being an x. All right. So in this case, it's going to be 1x. But assuming we had like a 4 here, so it'll wind up being a 4x. All right. So you just attach the x in front of that number itself. All right, are we done? Pretty much, but let's try to clean it up a little bit here. So cleaning up, we have x, now 3 plus 1, that gives me 4, over 4, which is my denominator, plus I have a 5x. Now my power here is 2 plus 1, that gives me 3, all over 3, all right? Plus x, then my power here is 1 plus 1, that gives me 2, so 2 all over 2 plus my x. Okay, are we done? No, we're forgetting to do one very important thing. Now at the end of my integration here, I must include my constant of integration, which is denoted by c. All right, that's very important. That is very extremely important. Don't forget that. Now why do we do that? We only do that in cases where we're not given limits. Okay, I'm gonna do a couple more problems where I involve a couple limits here. Now when you do have limits, at the end of the day, you're expected to come up with an answer which is just a number and not an equation like this, or a like just terms, like terms in terms of x. All right, so that is when you're given the limits. That's the lower limit and the upper limit. But in this case, we're just starting, so I decided to just do a problem, just a basic problem without any limits. And at the end of the day, this is my final answer. But again, remember, always include the constant of integration in cases when you're not given the limits. All right, that was problem number 1. Let's jump into problem number 2. Now integration is pretty simple, honestly. All right, here's number 2. It's pretty much the same as number 1, but for the case of just practice, let's just go ahead and do this one too. All right, so let's jump right into it. So my first term is an x to the 4, so integrating that will be x. Then my n is a 4 this time, so I'm just gonna take a 4 plus 1. Okay, just add a 1 in front of your power. All right, and then again divide by the power, overall power, which in this case is 4 plus 1, which gives me a 5. All right, minus onto the second term. Second term, I have a 5. Then I have an x cubed, so that will be x cubed. Remember, I always have to add 1. All right, and then I divide by the overall power, and in this case we have 3 plus 1, which is a 4. All right, third term, we have a 2x. I have a squared here. All right, I'm gonna add 1 to it, plus 1 divided by the overall power. In this case, I have 2 plus 1, which gives me a 3, plus x. All right, so x, remember, there's an invisible 1 as a power, and what do I do to that 1? I add another 1, so 1 plus 1, that gives me 2. All right, which becomes my denominator. Okay, finally plus a 2, which is a constant. Whenever you integrate the constant, you get a constant plus an x. All right, so in this case we get a 2x. Are we done yet? No. One more thing. Plus constant of integration. Why? Because I got no limits. All right, always remember that. No limits. Make sure you finalize your answer by including a c, which is a constant of integration. All right, so let's just clean this up a little bit here. We're gonna end up having x to the 5 over 5, all right, minus 5x to the 4 over 4, all right, plus here have it 2x to the 3 over 3, plus x. What is 1 plus 1? I get a 2 over 2 plus, plus a 2x plus my final constant of integration. And here you go, people. So that is how you find the integral of a function. All right, I am gonna do a couple more videos including limits and just harder problems. I just wanted to start off this with an easy basic problem so that you can get a basic idea. But I will be doing a slightly harder problem, which will be kind of good to challenge you and also learn more techniques and more strategies of how you can do all these calculations. Thank you for watching this video. If this video helped you out, make sure you hit that subscribe button, make sure you give me a thumbs up, and don't forget to share this video with your friends, and peace out.